introduce Heather, who's speaking first, and then I'm going to introduce Peter later on. And he's going to be online. So Heather, we have in person. So we're doing the hybrid of the hybrid of the hybrid here. And you can read about the program in the online information. And I'm going to read the bio from the online information, but I think, we're first going to read her bio. So it's Heather Mott, Collective Carpentry based in British Columbia. She's a leading North American manufacturer, pre-designed and custom super insulated wood-based structural wall, roof, and floor panels for thoughtful, principled, and environmentally sustainable residential, commercial, and institutional buildings. Heather is their in-house designer, certified passive house consultant. She creates pre-designed plans, integrates the collective building system into custom designs, runs energy model analysis, and occasionally brings her muscle to panel installs. A couple more lines here. With a passion for buildings that promote the health of the occupant and the environment, Heather's passive house devotee. She believes that homes built with an understanding of thermodynamics are most livable, durable, and beautiful. So please give a warm up to Heather.
Everybody.
Should be.
So I work at Collective Carpentry. We are prefab construction, panelized specifically in British Columbia, but we ship our panels all over the West Coast. Anything from the Rocky Mountains to the west is pretty much an area that we cover. We would go further east, we just haven't been asked. And it doesn't make a lot of sense because as soon as you go east, there's a lot of really great prefab companies on the East Coast. So what's important to note about our prefab, that we're panelized. So we're shipping our panels flat pack on a truck down the highway. That's opposed to modular construction or volumetric, which is like a shipping container size volume going down the highway. And if you need a graphic representation in person, I brought a scale model that's fun to play with. It's magnetized panels, so feel free to play with that later. So why do we do this? I think that the construction industry is a bit antiquated and we need to keep up with other industries that are advancing. I love this image of a guy trying to assemble his car in his driveway. We would never ask a guy to assemble a car in his driveway unless we're extreme hobbyists. And passive house, which I'll get into pretty heavily in a minute, passive house demands a lot of attention to detail and a lot of craftsmanship that we want quality control for. And the best way to get that, in my opinion, is with prefab construction. So I love this slide. I've used this slide on a couple past presentations to show that we started out. A great example of early architecture in America are homes that are very responsive to nature, building with nature. So I've got an example of the dog trot house here, which is a vernacular style of architecture that works with nature by encouraging ventilation through the home. Below that is the salt box house, which is a great example of architecture that is good for cold environments where it's deflecting cold winter winds, opening up to the south for a lot of solar heat. In the present, we have great advances in technology and standardization. We've got reduced fuel costs, and that's kind of led to this image here. I don't know, it's kind of small, but you might be able to see in all of the forced air condenser units, it says comfort in any climate. And we've kind of grown as a society to just accept that we can just build any house. It does not need to be responding to solar heat gains or wearing a really nice jacket, as how I like to describe having really good insulation in your home. And we can just build anything that we want in any orientation and just throw enough mechanical systems at it and it'll work and it'll be comfortable. And I think we can do better than that. So moving forward, we need to learn from the past of our vernacular architecture of the past, using standardization and all of the advancements in technology that we have in the present to create the homes of the future. So how do we do that? The whole theme of this presentation is healthy construction, healthy prefab. So my trifecta here is passive house is a key component to that. Healthy, quality, high quality materials, and prefab construction. And you'll see a lot of references to Lord of the Rings throughout this presentation, so get ready for it. They're all better at all help each other, they all advance one another. So for those of you who are very familiar with Passive House, I'm sorry, you're just gonna have to bear with me for the next 5 slides. For those of you who are new to Passive House, welcome. It is so much fun. And you're just, hopefully by the end of this, you'll love it as much as I do. Passive House has 5 main principles. And the whole goal of designing a certified passive house is this chart here, which is a representation of heating gains in a house compared to heat losses in a house. Most of the building elements are contributing to heat loss in colder climates. You know, it's all relative to your climate. But let's just say we're building in northern Washington State, because I'll do a case study on a project in the Mazama Winthrop area in a few minutes. Okay, so heat gains and heat losses is the balance. Everything in the home is contributing to heat losses, like walls. That's why we want really good insulation, thermal bridges, bad windows. If you have like a poorly designed window that doesn't have very good detailing, it's going to contribute to heat losses. But windows can also contribute to heat gains, with solar heating gains coming through the windows. Even our bodies are heating spaces. And so all of these factors play together, and you're trying to find that equilibrium. And where you need to make up for this big red bar here, that is your mechanical systems. That's the part that they need to add to your heat gains so that these find equilibrium. So the first step of Passive House is super insulated walls, roofs, and floors. This is like wearing a really nice jacket. We're all Seattle lights are in the area, so we all know our REIs and our outdoor researches. I think we can all get on board with just a nice jacket for your house. This is one of my favorite images of exemplifying this, because you can easily spot the Passive House in this thermal imaging diagram. Triple pane windows, again, super insulated windows. All Passive House certified windows have to go through this sort of isothermal diagram here, testing the window's performance. But this is just one small part of the window that makes sense for Passive House. The most critical junction is going to be where the glass meets the frame, so that gets heavily tested. And another really important part is how this window is installed in the wall. And that is where all of this could just go out the window, pun intended, if it's not installed correctly, if you don't have good insulation coming up over the frame. And so we do these as a just step 1 to pick your window. This particular one is by Veda. This is wood and aluminum clad, one of our favorite manufacturers. I don't have a partnership or any sort of affiliate relations with them, but they do superb jobs. So I like to give them a shout out. The third principle of 5 of a passive house is balanced ventilation with energy recovery. And I think Albert can probably talk a little about this, but I've got the floor, so I'm telling you how I do. This is a heat recovery unit on my left here, and this is the equipment that we're using to bring fresh air into the house, filtering that air, and it's passing through a heat exchanger. And the way heat exchanger works, there is a highly conductive core in this, which is this diamond shape here, highly conductive core. So the internal air coming through the house that's already been conditioned to a comfortable temperature passes through the heat exchanger, while air coming from outside, fresh air, is coming into the heat exchanger. They're exchanging heat, and you're filtering that air as it's coming in. It's a beautiful piece of equipment. Most homes do not have them, but more homes should. And this, I love this example here. This is a graph. This is a graph showing CO2 as it accumulates in a classroom. Just like what we're in right now, this particular study was done in Australia. CO2 it starts at about 9 a.m. until kids are released around 4 p.m. CO2 just accumulating and accumulating because this school was built code minimum. It did not require heat exchangers. It did not require fresh filtered air except for the occasional operable window. And this is just a really bad environment for children to be learning in. So if any building ever needs passive house, in my opinion, it's going to be hospitals and schools. It'd be nice to bring it to your home as well. And that's an important point I haven't made yet. Passive house can be applied to any building type. It's a German translation of passive building. So don't let the house in passive house fool you. It can be any building type. My other step.
Sorry about that. Now let's see others.
So heat exchangers are really great pieces of equipment, but they're most effective when we have really good air tightness in the building. When your building is totally airtight and very thoughtfully taped and sealed, you can control exactly where the air is coming into the house from. And this is just another diagram representing that more vapor is coming into the house through diffusion than through a hole. Vapor is really important in health of a building because vapor, moisture, condensation, mold, all things we don't want in a home, any building. I lost it again. And the last principle of passive house is reducing thermal bridges. A thermal bridge is anytime two junctions come together. In this example here, this is one of our roof panels intersecting with our wall panels, and we're testing, here's the original detail from the architecturals, and we're testing how heat is transferring through that relationship there. And we do a few different models. We're testing for psi value, which is the actual heat transfer. We're testing for RSI, which is looking at condensation. We want to make sure in the worst case scenario, the coldest day in winter, we're not getting any condensation because again, condensation leads to mold. That is not healthy. So we're testing everything really, really thoroughly. And all of this goes into a beautiful spreadsheet at the end, and we compile all of our results, and it's data-based. If you like evidence-based anything, passive house is for you. So that was the 5 principles of passive house. I'm adding my own 6th because I think it's really important, especially when we're talking about healthy buildings. It's materials. Materials are not talked about in passive house except for how well they are treating heat transfer between 2 elements. But I like to talk about materials, about what we're surrounding ourselves with, what we're putting on our bodies with. If we eat organic food, why do we not look at materials the same way? I'm not going to talk about this too much because Peter, my next presenter, he's going to dive into this pretty thoroughly because this is one of his passionate topics. But just a couple images here to show you what I'm talking about. This is our crew on a job install, and they're covered with, they've stuffed sheep's wool, which is one of the insulations that we use on our projects. They've got sheep's wool as opposed to those itchy fiberglass materials. You don't have to worry about that. They've got sheep's wool, they're just being silly, as opposed to a guy wearing a hazmat suit installing spray foam. Spray foam's okay, it's got its place in the world, but it's not in my house. So what does all of that look like? Those are 6 principles that I think we should use to be guiding our designs. This is the science behind it. This is the evidence-based architecture. This is where we're putting it all on the spreadsheet, we're testing it, we're verifying it, and not just in design. We're going into the field, and these are blower door test results. So we're testing for air tightness. Here's that beautiful thermal imaging model again. We're looking at, this doesn't happen with every passive house, don't let that fool you, but it's a good example of what we are capable of doing. Here's some of those hydrothermal and the isothermal images, and then up here in the top right, my right ear left, is a PHPP result. You've probably heard Passive House Institute and Theus are 2 different passive house certifiers. I work with PHI because I'm a Canadian firm. We work a little bit more internationally. So this is PHPP, Passive House Planning Package, and this is our verifications result. And that is showing the result from information like this, our psi values, and we're taking a psi value, that heat transfer through a particular junction, and we're multiplying it by the linear area of the house where it happens. So we know that we have a roof eave here. This is the psi value. This is how much heat transfer happens in this particular junction. And I know that it happens at 60 feet around the perimeter of my building. Boom, you have information that you can put into your PHP model to get a final result of how much heat loss that is contributing to in total. So how does that relate to prefab construction? Passive house is carrying the burden. Passive house has rigorous standards. It has a very important job. Passive house and prefab go together like Sam and Frodo. Sam Gamgee here. He's carrying the load. He says, passive house, I can help you. I can't do it for you, but I can help you get there. And this is how. This is the quality control that prefab construction is able to guarantee. We can do a lot in the shop that cannot, could typically be done on site, but this is how, this bottom long image here, this is how our weather barrier is being installed. We have careful precision. Our guys are comfortable. It's a climate controlled shop. And this guy, he just had lunch. He's using a bathroom just down the hall. He just heated his lunch up in the microwave. He drove 10 minutes to work. He's comfortable. That's how our guys are operating the shop. We have a lot of guys who transition from on-site driving to anywhere from 45 minutes to an hour and a half to get to their next job site. Now they know exactly where they're going every morning. They love showing up to just one job site, and they build panels all day, every day, various types, and we'll get into all the different types of panels, but they're very good at it. High performance is the only way that our crew builds. They're very good at it. These are just some examples of some of the precision and quality control that we're able to get in prefab construction. The bottom left image here, this is our lineman bridge. It's able to do some CNC routing. It does some nailing for on edge nailing, 6 inches on center, boom, 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 really fast, really precise. And then on the right, there's some panel installation images, very controlled, very, very careful. And our tolerances that we're working with are 1/4 of an inch. So very fine levels of detail here. So I like to demystify prefab as a whole. I think that's one of the barriers to entry for adopting prefab construction. And to demystify, we need to start with the process. How do we take a project and move it through our pipeline? On the far left, this is the first thing we do. Once we get the set of architectural documentation or an architectural 3D model, we create our own parts-based digital model. This is showing every single 2x4, every single hanger, every joist, every hold down, everything with a lot of detail. You can imagine the amount of information that we're able to gather from that. Material takeoffs, cut lists, order sheets, everything. So from there, we move to the bottom left image. These are shop drawings of every specific panel. We're able to break down the panel. We dimension it very specifically. This middle image here, this is in our shop. The next step is to fabricate it. And again, lots of quality control, climate controlled environment, lots of precision. And then step 3 is to deliver the panels, again, flat pack, so we're getting a lot of panel volume on a truck, and then to install. There are 3 ways that a project can move through our shop. The first is on the left. This is our collective homes pre-designed plans. Most prefab shops have them. We've just found that this is one of the great ways that we're reducing a lot of inefficiencies and making a few more barriers to entry, just knocked down completely, just offering pre-designed plans. The second step is through custom design. We have full service architectural design in-house. And lastly, a custom design from an outside architect. The examples here, the top one is Artisans Group. This is a multifamily project not too far from here in Tumwater, Washington, just outside of Olympia. And down below, this is a custom home design in Bozeman by Love Shack Architecture. Our shop has 3 different performance packages that we're able to offer with every project. The most high performance option is called our passive house wall. This is R55, very robust. The middle option is our high performance wall, R40. And then our third option is the net zero wall. You can get R25 or R30. All of our panels, walls, roofs, floors, if they're exterior, they're going to have insulation, they're going to have an air barrier, a weather barrier, they're going to be structurally sound, fire resistant, and they have an integrated rain screen. So there's a lot of control layers that we're delivering with our prefab system. This is a scope of work diagram. One of the biggest questions we get asked is, how do I prefab? What parts are actually prefab? This is the easiest way to explain that. We act as a subcontractor to a GC. Every project we work on requires the local general contractor. I speak a lot about we in collective carpentry. A lot of this applies to every panelist prefab company out there. Walls, floors, intermediate floors, if they relate to the structural system, which they usually do. And windows and doors are optional. We do not install doors and windows in our shop because of how we pack our panels is horizontal. And if we were to install doors and windows in the shop, we'd have to ship them vertically. We get a lot less volume, it's just more straight. Clicker again.
Oh.
Just continuing my goal to demystify prefab for you all is just a couple of design tips and tricks. So this is an example of how we frame rough openings in panels. The first example shows what we cannot do. We cannot frame a window between two panels. So what we can do, you can locate a panel entirely within a rough opening entirely within a panel, or for larger windows or something that needs to be centered that you don't want to locate the window entirely in a panel, is something like this, where it's actually 4 panels surrounding a window. And I like to say that this is the one dimension to rule them all, because with prefab, we're limited to this one constraint. 9'6", give or take, there's a lot of wiggle in there, but 9'6" is a good kind of general rule to keep in mind. That's the width of a panel going down a truck on a highway. And here's an example of how, this is one of our collective homes. This is how I optimize the design for prefab assembly. Instead of having 4 panels frame a window to have this window centered, I moved it off to the side so that it could be contained entirely within one panel. And that means I got away with just doing 2 panels here instead of 4. The benefit to that is it takes a long time to install 4 panels on site. It takes a lot less time to install 2 panels. We're trying to reduce our time on site as much as possible because that's a really expensive part of prefab. We're using a crane hourly rates are expensive. Our crew they are always mobilizing. They're coming from all over the US and mobilizing on sites. We're paying for their lodging, we're paying for their time on site is expensive. That's why we're putting as much into the panel in the shop as possible. So if we can reduce from 4 panels to 2 panels just by relocating the window a few inches, that's a good move. And I will say, we can prefab anything. So architects that might be thinking, I have a custom design and this is exactly how I want it, we can do that. We can do that. These are design tips for optimizing. This is an example of how we frame our rough openings. This is how we prepare them for window installation. This is really important because, like I was talking about earlier, with the triple pane windows being such an important part of the passive house principle, how they actually get installed into the wall is really important. So we prepare the rough openings with a self-adhered membrane. We have a sloped sill so that we've got good water drainage, and then you have little lips all over the place so that you can tack some rigid insulation all around the frame. Overhangs and roof venting are a little bit unique from site-built construction because we frame the main roof insulated panel as one panel, and then we have a second panel that goes over top that is uninsulated. It's just framing the overhangs. And so this is an architectural detail at the top that shows highlighted in yellow is the overframe roof panel. And yeah, so my last design tip is mechanical penetrations. I think this applies to most projects, but especially for prefab construction. You really want to plan ahead for your mechanical penetrations because we do build them in the shop. So here we have an example. This is how we prepare a rough opening. We use like a sonotube, a cardboard tube coming through the wall. We gasket it for air tightness, for weather tightness, and it's ready for shop drawings. And then here it is installed, ready for the ductwork to come through. We typically oversize them a little bit so that the duct can have some extra insulation around it, or you don't want to make changes that need a bigger duct and we don't provide enough room for it. So we generally oversize them a little bit because it's easy enough just to stuff extra insulation in there. And I know that prefab has a bit of a reputation for not being the most beautiful form of architecture, so I want to demystify that. Prove it wrong. We do some beautiful work. We have a lot of collaborators that are very talented designers, And I don't think that they feel constrained. I don't feel constrained as a designer. And here are some examples of projects that we've done with collaborators. On the far left, this is Maggie Design Build. They work out of Taos, New Mexico. On the far left, we've got Love Shack Architecture up in Bozeman. And then the bottom right is Artisans Group out of Olympia, Washington. The two middle images are collective homes. These are some of the pre-designed homes that we offer straight out of our shop. Which brings me to our first case study, which is a collective home. I'm going to be focusing on the Kalina, but we also have the Parian, which is about 1,100 square feet, and the Asta. And just to throw some more Tolkien words at you, these are named after Elvish words, because Tolkien is the best creator of words out there. So I went to his dictionary. So we're going to look at the Kalina design first. This is a project that we built in Mazama, Washington. It's just finishing up construction, and I got an email this morning with the blower door test results. So it's really close to being done. It's going to be Passive House certified, low energy, which is something specific to the German version of Passive House, the Passive House Institute. So it's about 1,500 square feet, 3 bedrooms, 2 bathrooms. Here it is in Mazama, if you didn't know where that was. It's kind of the North Cascades area. PHI climate zone is cold, and they had to create a custom data set for us. PHI was really generous, and they did this for free because they're competing with Theus. And so I like to give a shout out to people who do nice things for us. So thanks, PHI. I've mentioned some of our R values here. Some of our R values for the project here, we use a lot of dense packed cellulose, and you guys saw how that is installed with the big arm. The blower comes in, it gets the density right every time. It's a beautiful piece of equipment. Our windows are SmartWind Solar, which is a great window product because they're manufactured in the US, but they have the German engineering, it's German patent. So we really love working with SmartWind windows. And it's also a triple pane window, wood and aluminum clad. This project has a Zender ERV and a Mitsubishi ducted mini split. Here's an example of the wall. They went with the Passive House wall. Here are some of the PHI Passive House planning package results. I plugged that number in this morning when I got the blower door test. 0.51 ACH 50. That is that beats Passive House, full Passive House. We were just going for low energy, so it's really good. You are familiar with blower door tests. It's pretty good. Our builder really crushed it.
Yeah.
Thank you. Okay. So it's a happy day. So on the far left, we already talked about this, but this is our wall to roof. This is our psi value. So that junction went into the model, the energy model, and multiplied by the linear area, or the linear feet of how much area that covered. We had to do the same thing for our foundation. And this is our heat gains and heat losses that we talked about a lot at the beginning of the presentation. This is an example of the foundation. So this project is in a really cold climate, and the builder he's an owner builder, and he's building it as his family's vacation home. And he was worried about power loss and not being able to keep the building. So it's great. It's a passive house. Passive house won't last for weeks and weeks and weeks if you don't have any power. So he wanted extra belt and suspenders approach. He designed he and I designed the foundation to be for an unheated building. So the frost protected, shallow foundation for an unheated building. So it just has a lot of insulation. This frost wing here in this detail goes out 4 feet. So when you do things like that, you really have to think about the vegetation immediately around your building. But here's an image of the foundation. You can see the EPS and the Stego coming in over top. And this is how, in prefab, this is how we're doing prefab design review. We want to make sure that the architectural is matched in the prefab model. It's matched on the site when it's built. So on the left, this is our architectural model. This is a volumetric model. Elements are modeled as a mass. You draw a wall, it's a massive wall. Your wall is 17 inches thick, your wall is 17 inches thick. The prefab model, parts-based model in the middle here, this is very specifically showing every single 2x6, every piece of plywood, everything that's going into that 18 inches. And I superimpose them on this far right image here. this is how I'm checking my prefab model with my architectural model so that I know everything coming out of the shop is going to match my architectural drawings 100%. I superimpose the two, I play with the transparencies, and I'm able to zoom into every single corner of the building. Imagine the quality control we get when we're bringing like a construction administration up to the very beginning before we even start breaking ground. So we catch any sort of clashes. Things I've actually caught when doing this before are things like the overframe roof panels. They are for venting. We need venting in our roofs, and they had some blocking in them, and the blocking was not perforated. And we need venting, so it's blocking the venting. And so I saw this in the model, not something you would really easily see in drawing form. I saw it in the model, and I made a note, and I sent it to the guys in the shop, and they said, whoops, sorry, now it's perforated. There you go. How do you like that? Here's an example of what it looks like built. I tried to get the same exact angle. It always surprises me just how exactly similar they look. Here's some images of it after the panel install and during the panel install. Again, smart windows are really beautiful. The east facade here, typically in a passive house, your big windows would be facing south. For this particular house, the view is to the east, so it's oriented to the east. And so if it was facing south, we would have done a little bit more with shading, but we didn't need to because it's facing east. And here's a fun image of the rendering superimposed over the panel install project. So altogether, 1,500 square feet. It's about 6,000 square feet of panel area. It took 8 days in shop production, 2 trucks to ship, and 4 days to install on site to get to this level of completeness. The next case study, this is a mixed-use building in Tumwater, Washington, just outside of Olympia that we did with the Artisans Group. They are passive house experts, and they also really love prefab construction. So this is, they're the developers, they're the general contractors, and they're the architect. And this is probably our 10th project we've done with them. We have a really great partnership. So the top 2 floors are residential apartments, and the top 2 floors are the only floors that are passive house. The bottom floor is going to be the Artisans Group's new office, and they've got some other leasable retail space down there. So they used our passive house wall for the top 2 floors, and the bottom wall is our net zero wall, about R32. Here's some images of it being installed. So treated floor area, 6,700 square feet. Total panel area, about 20,000 square feet. Total panels, 196 panels. 7 trucks. 27 days in our shop to fabricate. 18 days to install. Here's what it looks like today. It's almost done. And that's all. Thanks, everybody.
Let's do that. That is passionate passive house powerhouse and a passionate prefab powerhouse. Fine. Really nicely done. So there's 3 plugs for you in between, and we're maybe still working on tech to get Peter up for the next presentation. I'm gonna make a short plug. Rebecca's gonna make a membership plug, and Aaron's gonna make a plug. And we have I don't know the best terminology for this, but a sister organization up in Whatcom County. And you guys, I'm sure I'm gonna see you on Friday over at Martha Rose's house. There's a green home tour put on by Sustainable Connections. It's happening actually today, tomorrow, and Friday. So they're instead of the way we do it here with our green home tour, which is everybody on the same day, they split it up. They had a pre-funk party on Tuesday, and then they have 1 house a day for 3 days. So I encourage you, if you have the time and inclination, to go check it out. And Martha Rose's house will be on Friday, and there'll be a party. With that,
Our Zenith project is on.
yeah, I want to see that one. I'm hoping to get there tomorrow. Thank you. It's on my calendar for sure. Thank you. Yeah, really want to see that. Not tomorrow.
Oh, you can come, if you come up Friday, you just, we'll be there.
I gotta go up there and help Martha get her house ready to roll.
Well, I just want to say, Heather, you should be the ambassador of Passive House. Like, your enthusiasm, I'm just like, yes. So I'm Rebecca. I wear many hats for the Guild, but I am the membership coordinator. As Sage referred to earlier, we are rebuilding the Guild. We're post-pandemic. Our first meeting that we had here in January, there were 5 people. We've had upwards of 60. This is becoming standard and bigger than this. So we are growing. And to do all the great things that we want to do, we are membership based. We need you to be part of the team. I want to do a quick tally. Who has joined the Guild in the last week? Thank you. The last month. The last 6 months.
I don't know what I reviewed.
Well, we're getting to you.
Oh, okay.
5 years. 10 years.
Not currently.
Renewed or joined?
Joined.
Joined.
I'm basically trying to get a sense of how long you've been involved. 20 years.
Yep.
Okay. I'm in 10.
Almost 20.
30 years?
Maybe 27, 28.
Okay, we got you back in there. John Alexander, the founder, is not able to be with us today, or one of the key founders. So the point is this is a community. This has been a community that has been building and supporting each other for 30 years. I have this handy little QR code right here. That you can use your phone to become a member. You can also contact me, membership@ecobuilding.org, and we can find the right membership for you, your company. We have small business, we have medium business, we have large business. Someone made the suggestion that we could give them our value levels, just to make it a little more fun. I think we may have to do that. But we do these educational sessions, we network, we support each other's businesses. We're just a creative force, and we would love to have you join. So with that, I will give you over to Aaron, who is our new co-chair of the Education Committee.
Thanks.
This will be right here.
I know y'all are probably really excited to move on to the next presenter, so I'll make this really brief. These education sessions are, I think, really important right now. I believe in that. And if you didn't, I bet you would be here today. You're getting something out of it. It takes some work, and it's a good group of volunteers, and we have a lot of fun. I just want to put a plug to the Education Committee. If you want to, get involved. We are revamping the Guild. It's coming back alive, and the education events were why I joined and what made me stick. And yeah, there's lots of work to do, and if you want to know what that takes, just to leave in a little bit of support, come talk to me, come find me before we're done with beers.
Nice.
Yeah.
And Aaron, are you going to be rebuilding committees and things within the Education Committee?
Let's talk about that. I'm brand new on the chair. So yeah, I'm very open to ideas. Yeah.
Yeah, thanks.
Yeah.
So with that,
Thank you.
you have a question or a comment?
Is there time for questions about?
Yeah, just about this, there's also one question online too.
I think we should.
Yeah. I think you want to field the question. Thank you.
I'm done. How do you handle shear wall inspections with your assemblies?
Yeah, we've got a few ways that we do that. The most common way is we take really thorough photos during construction in the shop, and we send them to inspectors. If we're working in jurisdictions where the inspectors want more than that, what we've done is we'll have a third party who's local to our shop come out, and he or she will do the inspection and then send a report to the local inspector. Still not happy, the worst case scenario we've only had to do once is fly the inspector out to our shop. Yeah, because we installed panels on site, they're closed. They're insulated, they're wrapped, so if they want to see that damage pattern or blocking anything like that. Yeah, that's worst case scenario, we're going to do that once we built hundreds of these. Yeah. Anything else?
One more question online, is that right, Steve?
Oh, wait. I was just curious why Artisan Group didn't do the bottom floor as passive house.
It's tricky in mixed use buildings. You see it actually quite a lot. We've got a couple mixed use projects that are passive house throughout Seattle. And they'll treat the upper stories as passive house, but not the ground floor. Typically, they want more glass. It's really expensive to do that sort of storefront glass as passive house.
Ventilation can be a problem if it's commercial restaurants and there's other,
The use model.
typically, commercial spaces are left out of residential buildings quite often.
Yeah, I guess I'm plugging commercial because we just finished commercial, so I want people to not
And
shy away from commercial.
Wonderful to be
either.
wrong, right?
Yeah,
Don't learn new, yeah.
but I get the kitchen. Yeah, cool.
You're probably also selling the cladding and it's.
We can do doors and windows. We do not do the cladding.
How often are your panels installed by non-carpentry vendors?
We can. What we can do is send a site representative from our crew who could just sort of be the coordinator, orchestrator. But we've done a couple of installs where we just send the panels and an IKEA instruction manual, and that's gone really well too. So if a contractor was interested in taking on that scope, we're open to it.
How are they connected?
Yeah, that's a very there's a lot that goes to that because there's a lot of different panels and things. But the short answer is for a wall to wall connection, we'll usually install one top plate in the shop. The second top plate will install on site and it'll overlap both. So that's one way. The other way is if you look at my skill model over here after all of this, we actually leave a gap between the two 2x6s so that we can get in there to tape for air tightness between the two wall packs. We'll tape for air tightness and then we put a flat 2x4 and we just anchor it into the sheathing and then, into the two 2x6s. So there's a lot of nails that go into it. Other things, of course, we've got like anchor bolts to get into the foundation, pull downs to the foundation. Yeah, there's a lot there. We've got standard details.
Yeah, I was gonna say probably details of all this stuff.
Can you give a cost comparison between code and a passive house?
Yeah, so we've got the 3 different wall types. In Washington State, our lowest performing wall type does meet code. And so you could do a cost comparison between our passive house wall package and the code minimum, essentially.
Can you do that here or look at each design individually?
Each design individually. Yeah, we can give you rough numbers for like panel area, but it's a beautiful spreadsheet, so.
Okay.
When it's
So are all mechanicals? Or
Yeah, that's a great question. So our passive house wall has a 2x6 that is uninsulated when it's installed, and that's for running services like conduit and things like that. Yeah. And then typically that's just installed with that insulation on site. Whether the homeowner wants to.
that's part of the 2x6.
With the cellulose insulation, is there any risk of it settling at all, or how do you mitigate that?
Yeah, it used to be a problem of ours. That was sort of a growing pain because we used to use a tube blower to install it. But since we upgraded to the ISOCell blower, which was that big square arm, the density is perfect every time. So
Okay.
the answer is advancements in technology and automation is how we solve that problem.
Got your three different wall systems. Oh my God, how thick are they?
Yeah, so the lowest performing wall is called our net zero wall. That starts at about 9 inches, give or take. And then the most performing wall, the passive house wall, is about 18.
That includes the service wall.
Yeah, in both.
I thought that you guys used a wood fiber installation. Or you have?
We did in the past.
Okay.
We don't anymore. For our net zero wall, we're using mineral wool now.
One of the questions online was about the roofing material they used for I forget what the name of one of them was.
Helena?
I think so. Or what your
Like the
go-to
WRP
roofing?
underlayment.
I think they're asking about roofing.
We don't do the finished roofing material, that would be the GC, but we do a temporary roof underlayment, and we tried to stay brand agnostic, but we really love the guys at 475, so we use all Proclima membranes right now. So on the roof, we're using things like Adhero, which is on the scale model over there, if you're curious what that looks like. And that's a temporary roof underlayment. And the first thing that we tell the GC when we leave the site is to get the actual finished roof on, because that's a really stellar membrane, but you just want to protect your roof first. Anything else? Thanks, guys. Good question.
Yeah, I have several questions in the chat.
Thank you again, and thanks for being in collaboration to remember the questions part. We're in this together, so it's hard to remember all the things to say, all the things to talk about, all introductions on everything. So are we ready to roll with Peter's presentation?
I think so. This might be one of the first, I don't know if we've had a virtual presenter in our new version of hybrid here. So we're gonna risk it and maybe experiment, see how that goes, and
We're gonna,
bear with
it's
us.
your top experimenter right here. I'm gonna make an introduction.
So Peter, if you want to share your screen, we'll get you set up here while Sage is making your bio and intro.
Excuse me, could she still answer my questions that are in the chat? None of my questions have been answered.
Kathy, we're moving on to the next presenter right now. What about if we collect those, and if we have space afterwards, we'll read them back.
No problem. Thank you.
Thank you.
Thank you. Yeah. So we got Peter Jensen coming up, and I'm hoping I don't butcher the way that you pronounce his company name. CEO of Build with Nature and North American representative of the Eco Cocoon prefab straw bale panels. There's some O missing in cocoon on this spelling. So anyway, that's a carbon storing construction system based on the cradle to cradle philosophy, making the best of natural materials, timber, straw, and clay, while ensuring maximum indoor comfort and health, energy efficiency, and reduction in CO2 emissions. Peter is a Danish designer and building consultant with over 20 years of experience in natural building. Pretty cool. He has traveled the world, leading various humanitarian projects and constructing sustainable homes, schools, and community buildings. So please give it up for our experimental first virtual speaker.
Thank you so much, everybody. I hope you can hear me. I hope the sound is okay.
Yes.
We've got you loud and clear now.
Working.
Oh, great. Wonderful. So I don't know if you have my presentations or if you use the presentations in my end. What is best for you?
If you're able to share your presentation, that's probably easiest. That way we don't have to do the next slide.
Okay, so let me bear with me for a minute. So can you see that now?
It's just it's coming up. It says you started. There we go.
Here you go. Wonderful.
Yeah.
Thank you so much.
The other
Thank
people in
you.
the waiting room see the presentation.
Yeah.
We can see it fine.
You can see it fine. Great. Wonderful. Thank you so much. It's an honor to be able to be invited here. I wish I could be there in person, but it's wonderful to be here. And so my name is Peter. I represent EcoCone in the United States. So EcoCone is a straw panel construction, so we go much deeper in that. So we're in 29 countries, and we're building around 500 homes at this point. And then I have my own company that is I have a building company where I'm the construction where I'm the DC for many projects in my area. And then I represent EcoCone all over the United States. So I have working on 22 projects in 7 different states. So all the way from California to the West Coast to the East Coast. And so you see, I can slide to the other side. Give me a minute. There you go. So I hope you can, it just take a longer time for them to slide. So bear with me for a minute. So here we got a new slide. So good. So we built so close to natural materials. Why I have the passions of building with straw. In so many cases, even in natural materials, even wood fiber, cellulose fiber, even in hempcrete, we change the materials. So straw is one that is completely a raw materials. They have their own fire resistance in it because we have so much resins in it. So it's own, all self-protected flammable. So we can have over 2 hours fire rating on it. So what we are very good at is to compact it in a certain way that we can keep the highest arc value and the most safe for fire. And here you go. So the EcoCone panel. So here's a little bit about the overview. So the EcoCone panel that is easy and fast to construct, that have the energy efficiency of the passive house that Heather talked about that we're living up to. They have the carbon storing, a carbon sequester. And we can design and build any homes you can dream of. For us, it's very important that it's with raw materials, so no toxins materials in any of the buildings, in the wall, the roof, floor, kitchens, all over. So for no toxins. So it's built to last. And why we're building the store and why regenerative farming is a big part of what I'm doing. And I will show some of our projects that we're working on. So some things about the EcoCone panel, you can see one of flying there in the air. So what is different for us, so we're doing prefabricated straw panels. So we can work with any designer, any architect, and we can prefabricate anything you can dream of. What is different from the more traditional way we do it, there was the stick frame, you go to local lumber, you cut a lot of 2x6s, you assemble everything's on site. And then you have like Heather, they have a bigger panel that's already done in indoor in a climate control area, and where we a little bit in between. So for us, we do want to do some things that even let us say that if you're a builder or even a homeowner that wants to build your own home, even you're only few, 2-3 people, you have successful to build your own home. Some things that you can move around with, easier to build. Everything's this prefab. Or we can do, right now we're doing a big buildings that is 1.6 million square feet. So we also do large constructions where we're putting all the panel inside and then we bring it out like Heather do. So we can do both to serve a small company that want to have successful to put it together, or we can serve large company that want to do larger scale project. And so we have 6 different kind of panel type. So all that as the both as a homeowner, architect, designer, you don't need to think about. We do take care of all the engineering, we do all the modeling, this all on us. But it's a little bit about, the panel. So the smallest one we can do that is actually 11 in a 3 1/4 by 3, all the way around. So us is so 3 meter or 10 feet tall is the highest, and we can do it for millimeter precision. So we can produce any panel we can dream of. At that moment that is more than 10 foot tall, we continue to stack them top of each other. So for the most area, we could at least go up to 3 store without any problem. Some area we allowed to go up to 6 store tall, just with a store panel. So the store panel is take a little bit, you can see it already there. So it's a 2x4. There's a double stud, so we have one outside, one inside. And then we have the standard panel. This and we're putting it in pretty much everywhere where just continually. And then we have a bridge panel. So we prefer don't to have a plywood outside. One of the things that we have seen over time, for us, our building, we don't want to last for only 50 years. We want to have, 150 years. We don't want to see the end of our lifetime of our building. We see some issue where we see mold issue or a long time see on the plywood outside. So we prefer to don't have that. So we have the bridge panel is putting in. So we don't use so it's then take care of the buildings don't go for one at the side. So the way we can brace it up. So you can see sometimes be having the brace panel in the middle. Then we have the column. Column can take the roof load. So it's extra strength in the buildings. And then we have the lintels. The lintels that is above the windows. Then we have the sill that's sitting below the windows. And then we have the decliner if you have any angle you can dream of. And then we have the incliner with the brace panel. And so it's a little bit about so we have three different kind of panel. So one of the largest one, the most standard panel, that is 400 millimeter or 15 on a 3 1/4. So we're close to R40. They have a other one that is 13 and 3 1/4 or 350 millimeter, and around R35. And then we have the smallest one, little less than a foot, and 300 millimeter to R30. So all our panel is certified. This to passive house, have a fire rating of 2 hours, have a very good for sound absorption. So if you want to go for full to passive, what we most of the time do, then we adding a wood fiber board on the outside, so we're getting very close to R50. That gives us also a lot of advantage that we like to plaster a lot of our building. So we're having I'll come back to that later. I want to show some of the way that we do. So it is but special from here that we're doing in like the small block. So we can building around with 4 or 5 people. We can build around 800,000 square feet wall area in a day. So this one, you can see the first picture that is we have been on it for around 2.5 days. So for the last buildings where you can see everything's have a 1,000 about it, around it, air barrier, we have the roof tosses up in day 4. So we can close this building is around 2,300 square feet, and it was all closed in. We have windows in and everything's in around 7 days. So the panel is very easy to put together. And then like we have every details like here they have, so we have everything's coming in a container, and everything is labeled. They have different color codes, so you can see exactly where in this container, where it belongs, so you can easily put it next to where you have to build it. And again, the super high performance we want to use so less energy as possible. So the most of the buildings we do is off the grid. We often see that is sometimes the most efficient, the most affordable. If we list it out around 10 years, we typically have gained the more extra cost we're putting in. The most of the project we have already gained them back again. And we're one of the only one, as far I know of, the both holding the passive house and cradle to cradle certifications in one. So the most of the people that we're working with, I would say 99% of the people we're working with, they always have clay or lime inside. We want to don't using drywall. We want to use no toxins, the best materials, so close to nature as possible. Some things about clay is amazing. That it's incredible to regulate our humidity. We like to be in a temperature that around or humidity that's around 55%. If that is less, if that is more humidity in the room, the clay absorb it, and if that is less, they give it back again to the room again. So you always have this nice indoor climate with a humidity. And if that is more in around 75 Fahrenheit, that we're starting the clay and the straw absorb that extra heat. Again, if that is getting cold at nighttime, they give it back again to the room. So we have inbuilt like a climate control in the combination between the clay and the straw. I often say that there's some things about like art value is not art value. Fiberglass, if you took a cup and you're putting hot water in, and if you put it in a glass cup or you put it in a wood cup, and if you took the glass cup, you will probably burn yourself, or at least be very warm, because a wood cup you will not really feel it very much. So glass is where the heat going out very quickly, where straw or wood, like cellulose fiber, like heather do, or wood fiber or straw, all contain the heat for very long. A typical say that if a bird make a nest out of spray foam, fiberglass, one thing is the health issue that will come out of the bird if they try to did that. The sad story is exactly how we built it. Today I was home. But even then, the egg will never hatch because too soon the mama bird have left. The heat going out very quickly. Whereas straw, wood, they stay for a very long time. And some of the things about, so we're building our raw materials, and the good things about it, we can build all over the United States. So we can be successful. We can build it in Florida. They can take the humidity. We can build it in a way they can take the hurricane. We can build it in California. They can take the earthquake. They can take the wildfire. We're building one right now in Colorado. They can take that area that can have to be withstand more than 260 miles per hour. There is a wildfire coming through. I have been there quite often. So it is built to be able to take the wildfire. And we can build it in Alaska, and we can be successful all over. So it is made out of natural materials and designed to be able to handle the nature. And again, this meant to last. I have taken buildings out or take a building down with straw that was more than 360 years old, and the straw still smell of straw is crispy. So if you do it in the right envelope, you're able to keep that buildings for very, very long time. I could just go one back. So the most of the buildings we putting a lime plaster outside. So the good things about lime, we don't really have any maintenance of that plaster we use is a product coming from Baumert. So you can choose any color you can dream of. They have it's a quarter in thick, but it can last for at least 100 years or even longer. The good things about lime, after 10 years is strong, after 50 years is strong, much stronger. 100 years is way stronger. Lime is dust powder. But that moment, over time, you're more sunlight you'll give it, you're more rain you will give it, you're stronger it will be because they want to go back to be a lime. I'm sorry, to be a stone again. So a lot of our clients don't want to have any maintenance, so they want to have one bill, never see a bill again. So the most of them is off the grid, so you don't have a heating, cooling, and any maintenance for a very, very long time. So our client, we not necessarily, sometimes I am the general contractor for a lot of projects, but we serve builder all over the United States, the people that want to, from small company to big company, that want to do prefabricated. So only few people can put it together and get successful. We're flying out to and teach them how to do it. We lead small teams or bigger teams, how to put it together, quickly and efficient. So I think we already have been over the most of it. For how we build it. And then so we working with any architect. We can take again any shape and form. They could be even to be round or curve shape. We can do that one as well. And a lot of architects like to work with us because a lot of the only things that they need to do, that is to only take care of the thickness of the wall, and they can just have the freedom to design because we can prefabricate it out of it, and it's us to take care of all the engineering that is in the area that is needed. So right now, we still import all our product from Lithuania, from Europe. I'm working with other team are creating another company called Nature, where we try to get the first production line here in the United States. We hope to have 7 production lines across the United States. So each production line can make around 500 homes a year. So we're using ancient materials that we have built it for thousands of years, but we also take highly robust AI computer program to be able to do the prefabricated so very quick, very rapidly, and I hope over time to aim to make them very affordable as well. So just a little story, sometimes to start small, than most things do. So it's my dear friend Lars Keller from Denmark. He took his bike and he took to the capital city of Denmark. He took his little store building, some of the smallest one we actually do. And he go to a different firm and he knocked on Henning Larsen's architect firm and he said, what about building something out of straw? And he scratched their head and said, yeah, that sounds interesting. Some things they have designed, they want to do something prefabricated, they want to do something that was lasting for a long time, something that is passive homes, no toxins materials, how we can sequester carbon, sort of pretty much fit all the boxes. So just know Henny Larsen is a huge architect firm. They're making normally $1 billion project, huge. They're making cities, so they're making huge buildings. One of the things, this one of the smallest building that did is a tiny school in Denmark. That little school, they get a lot of publicity, probably more publicity in any of the $1 billion project, because there was something that was very unique. I'll go a little bit back to that, but straw actually can do. But for that buildings, the next one they're actually working on right now is the logistics center in Netherlands that is 1.6 million square feet. So it's in 3-story building. It is huge. It's one of the biggest timber buildings in Europe, the biggest straw constructions in the world. And then we're doing one of the highest high-rise buildings made out of straw as well in the world. And so it's a 12-story buildings. We have over time we still try to figure it out, but we close to, at least we say that we build quicker, and in the most time we're also more affordable in concrete and steel. And again, the millimeter precisions, in that moment we're going up to more in 6-story. This one is 12-story. The skeleton we will use, that will be mass timber or CLT. So only the exterior wall is being used as just our store panel. So why building with straw? Or why have that my passions, and why I think that is amazing materials? One thing is that we have a lot of it. So around the globe. So if you want to make all the buildings made out of straw, not to say that we ever do that, but if you want to, order only 10% growing straw in the United States can take care of all the buildings we will do annually in the buildings around across the United States. So it's the materials we have so much of. So I know we talk about climate change, and if a lot of people put the focus on mass timber, and mass timber is wonderful, it's great, but we don't have that many trees. If you want to do all the buildings to solve, the whole world's climate change and the challenge we're facing with that, just with mass timber alone, we pretty much a couple of years we have no more forest left because we don't have enough of it. Whereas straw, we have abundance of. Besides that, there are some things that we often talk about EPDA. So EPDA only talk about carbon storing in a building. But if something happened before they enter the buildings and having all the way back from the ground. So we have the conventional farmer. Around 98% of our agriculture today is highly chemical. We're using Roundup, glyphosate, pesticides, glyphosate, using more than 16 different kind of chemical that you're actually not allowed to use in any other country around the world. We also put 10,000 more substances we put in our food. You're not allowed to put in any other country, only in the United States. We also become the sickest population. We're using $3.4 trillion in healthcare in the United States. we live in 7 years less here in the United States than you do in the most of the country in Europe. So we're doing something with both our soil, our food, and our building. And at the same time, we also release our lack of good the lack of good topsoil. So the topsoil can be so poor, we call it desertification. That is so poor that there's no mineral, there's nothing left to turn into be a dust. So we have it the same size of England. We're losing to desertification where we not can grow things any longer. So then we tilt the soil, use a lot of chemical, we deplete our soil. And so we talk about we have around 45, 50 harvests left, then we have no more left. We have to change the way we farm and the way we grow. There was all the bad stuff. I want to go back to all the good stuff. So if you're taking just a conventional farmer and we're so proud of it, okay, we're storing 40 tons in our buildings, but we don't really looking where is the straw coming from. So if you're just using, where we tilt the soil, use a lot of chemical, behind our back here, I actually lost 52 tons of carbon. But in that moment, what we use regenerative farming is the other farm method where we don't use any chemical. We're using a lot of different kind of plant, a lot of kind of cover crop that are able to draw down and take the mineral from the atmosphere and turn it into get all the nutrient and mineral back again in our soil and actually building up our topsoil. If you're losing 1 inch of topsoil, that will take nature 500 years to build it up again. The cool thing is about it, if you farm and we use our animals and our crop in the right way, now we can build up topsoil around in a year. So we can build up topsoil. The good things about it in that moment, we produce real organic food that is full of mineral. In that case, we take the leftover and we putting in a buildings, and we can storing a building. So between the sequester back again in the soil, the compounding over year, and in the buildings, now we have sequestered and store more in 100 tons in a building that is around 2,000 square feet. So do a little bit more quickly. So we're taking about what we talk about the carbon. So this one, the first column from you to the left side, that is a passive home. But all the dark green bottom that is made out of spray foam. So the dark green is the embodied carbon energy that we use to just making the buildings, the passive homes building. And the top one that is a little square that is like 48 tons, that is the energy that we used over 30 years. So we don't use much energy, but to just making your passive homes, you have already used a lot of energy. We talk about up to 250 years energy consumption to just make your passive home if you do it out of spray foam. And actually the middle one is actually also made out of straw. So if you're using straw from a farmer that using a lot of chemical and tilt, you have released a lot of carbon behind you. And the other one to your right side, that is where you can see how much carbon that actually be sequestered back again in the buildings. Back again in the soil and storing in the building. So combined, you have storing a lot of carbon and sequester a lot of carbon. And for me, my passion is not only sequester and store carbon, but also showing out of a building out 2,000 square feet, we actually can produce 38 tons of real organic food. And we can build up around 3,000 tons of topsoil we can build up. So we solve some of the biggest challenges we're facing in the world, that is building up topsoil, produce real organic, healthy food, and we can make incredible, healthy homes that can last for generations to come. So This one is just to show a little bit about the power. I think the both the sequester the carbon and storing in the buildings. If we talk about there is we spending billions of dollars how we can solve the climate issue and how we can store carbon. The cool thing is about it, nature do it all day long. The building industry is one of the biggest industry in the world, and I'm here to make so much research, and I have big architect firm we're working with around the world to showing all the data I'm showing to you right now is actually proven. So we're still working with a lot of peer reviewed data, so it's more will coming. But just to show, briefly, so I know we will never do that, but if we did, if you took all the buildings be made out of globally made out of, in that case, straw, we have sequestered more in 20 billion tons of carbon and storing back again in our soil. If we did that over 20 years, let me move this one in a minute. If we did that over what we have released in more in 275 years, if we did that over 50 years, we have, we will have stored and sequestered all what we have released in the last 275 years. So we did that create a lot of hope. We have a way we can solve the climate change issue we have. So sum it down, I think my core value is to change the mindset how we have think for a long time. For so long time, we have a mindset how much can we extract and how much can we take from nature and how much can we profit from it. I want to change that mindset to a whole other way to think. In that moment, we can co-create with nature. So how much can we enrich our soil? How much can we enrich our food, our farmer, our community, and each other? For me, that is only wealth that will continue to grow. So upset together, we can build a better future today for us, for the people on the planet. We can grow our home, our cities, and we can heal our soil, and we can feed everyone while we sequester carbon. So that was all what I have today, and I'm happy to any questions you must have. I'm grateful to be with all of you.
Questions, house or online?
Yeah, I have some questions in the chat if somebody wants to read them from the room.
Sure. Let's see which one. A burning question you want to just ask out loud, or do you want me to pick one and read one?
Well, one thing is, I live in Eugene, Oregon, and the University of Oregon did some dew point studies from the Department of Architecture. This is about 25, 30 years ago. And there was a straw bale dormitory built at a nonprofit group out in the country. And based on the dew point readings, the director of the nonprofit institute decided to not recommend to his mother to build a regular straw bale house in the city of Eugene. And so I just wondered whether dew point is a consideration. You say you've built in like 500 countries. So I'm wondering about dew point questions.
Thank you so much for your questions. So yes, we are building around 500 homes in 29 countries. We're building pretty much any climate zone you can dream of. So it's very different. I have made a lot of straw bale buildings, but this one is a whole that is the same as heather do. So we're using a lot of product from 0475. So everything is roofing calculations, everything is humidity control. So we run a lot of calculations for that area to be sure that all the dew point is never happen in the buildings, but happen outside of the buildings.
Great. I have one other question. I've been very interested lately because I'm an older person. Are you familiar with Charles Zeiss, Ziese? He currently lives in Harrisburg, Pennsylvania, but he used to be an investment banker who's gotten into the 76.345 angle pyramids for about 8 years. And he has a video, it's 5.5 hour long on YouTube with 1,000 pictures of around the world of the 76.345 pyramids, including the American Indian teepee. And this particular pyramid, when it's put near a farm or a garden, can increase the production of the harvest by 30 to 100% and potentially increase lifespan 5 to 15 years and enhance the ability to do psychic readings or astrology or meditation. And finally, there's 18 of these pyramids built in Russia by a Ukrainian man who the athletes go to visit them before they do sports, and they can produce free energy at about 4/5 of the way up the pyramid, according to photographs from planes. So, are you familiar with the Pyramid Research Foundation, or Charles Ziese?
Not to the full extent. I have some experience, but we're working with the same mindset. So I have a whole other group of people that we try to work with architecture that is able to, what you said, increase both health, the life long span, and so yeah, we're working on it. But I'm not so familiar with exactly the gentleman you talk about, but we're working on it. Yes.
Well, I just want to suggest that he's using plastic tubing, and I called him in Pennsylvania and asked him if he could use hemp PVC tubing, and that doesn't exist now, according to Jean Lotus, the author of the 700 building products made of hemp, which is in her 4th edition this year. She said there was no hemp.
Kathy, we're going to come back to some questions we have in the room. Thank you so much for all that information. Yeah, we have a question over here, Heather.
How is the insulation prepared? How is the straw prepared from the straw form insulation?
So Heather, I could not hear your questions.
And the question was about how the straw is prepared. Can you speak more to that?
Yes. So all the panel, what you can see, so is all coming. So the panel is a 2x4 double studs and have all the straw is compact. So all that is happen in our facility, and if we brought out that is so compact, so you can fall over, you can do everything you can. It's very compact. You can not even put your finger in. So that is so it's a stud frame that you have, and it is compact with very dense straw.
I just want to make a little plug. One of the things that CASBA was finding, the California Straw Bale Association was finding, that because of that density of the pack, they just ran, I think last year or so, a full fire test on bales, and they're noticing that because of the density, it doesn't, there's not enough air for it to catch. They're just smolders.
Yeah, so
we have process that happens to the raw straw before it's compacted. And that was part of the question.
Yeah, there's nothing just in the straw, right?
Okay, thank you. Yeah, so what is different for ours, we have 50 years warranty in our panel. So we all the straw is not made up. So coming from a straw panel, we split the entire straw panel up. We sort it out, take all the dust out. If there's anything that we don't want, we go minuscule of any straw. So we be sure we put it in right and properly, so they have the humidity that we want. And then we have different method how to put it together. We have different technology. Yeah, so everything. So the most straw bale buildings and straw prefabricated straw panel company around the world using straw bale. But at the end of the day, you will not know what is in the bale itself. But if you split the whole thing up and start all over again. So far I know of, we the only straw panel company in the world that split the whole thing and put it together one more time. Yeah. I hope that answers your question, Heather.
The straw dried, or is there some process for going from the field to into the bale? Is there like a drying process and you're achieving a certain moisture content, et cetera, before it actually goes into the frame?
So they can dry out naturally. So we don't do other than just what nature are good at. So we want to keep it down to around 8 10, sometimes 12% around that area. So that is the way we can start to put them together. So they can dry it out. We don't use any way to just let nature do it. Take the time to dry it out, that humidity that we want. Mhm.
Where are they made? In US, right? Or where are you making the panels?
So right now we do make them in Lithuania. We also have a production site in Czechoslovakia. So we want to do them locally here. So I'm working on try to get a production line here. So we still a couple of years before we can do that. And again, now we talk so much about environment. We talk about carbon storing and why can you justify it? Bring it from Europe all the way here. So for me, the only way in the long run have to be done locally. They have to be by regenerative farming, done locally, building up soil, produce real organic food. Right now, I can justify it because we have the technology there. And we need to have a big volume to be able to get the productions here. But to a boat, like I said, a boat from Lithuania to, in that case, New York, where I am. So there will be, just according to the boat, we put that on a truck, there will be 1.5 hour of energy consumption, put it on a boat from Lithuania to New York, the same of 1.5 hour on a truck. So even sometimes I can building homes here in New York there will be the same amount for around 6 hours in a truck driving. So if I have to get a straw, let's say from Maine and Vermont higher up, they will actually spend more carbon, I will release more carbon to tow them for a long distance, more than 6 hours. It's actually better to bring them from Lithuania. So this is the way I still can justify it as now. But again, in the long run, I want to do it locally. Yeah,
Peter, just to clarify, you are in upstate New York, right?
I am. Yes.
I have a question about plaster. Could you just talk a little bit about the difference between lime plaster on the outside of the building and its principles and clay plaster on the inside and its principles and how they differ? I know there's some durability, differences in those different products, but maybe you could speak to those and how they're different.
So, or if you go into a new area, we always use roof calculations. We have a lot of data to show exactly, how we're building up our envelope, so we know if everything is done properly. So we often be using again lime, clay plaster inside. So we having typically we have around 1 inch of clay or lime inside, and then we have around a quarter inch of lime based product outside. I hope that answer your questions. One thing is I can say, but I love about clay. Clay can do some things. Besides that, it can store to be a lot of mass in the buildings. Both the straw and clay can do that. But if you again, if it's more than 75 Fahrenheit, they take it up again, so to take it into themselves, and then it's less, they give it back again to the room again. So we're less concerned about overheating because we can take a lot of heat into the buildings, and the clay and the straw can take a lot of it in, where drywall don't have the capability, but clay or mass can do that. And we have a lot of mass in our building. We can have up to a 2,000 square feet. We can easily have about 25 tons of just clay if you have it everywhere. So they can take a lot. And again, the humidity imbalance. So why they can absorb so much humidity? And if you took a square cube of a square cube, it's an inch square cube, so it's an inch by inch by inch all the way around. And if that was like a stone, you will fold it out. You will have around probably about 6 by 6 inch because you put it out. If you did that out of the same with clay, and if you have the same surface area for clay, you will have a whole football stadium. Why? It's because clay have so many small, tiny, fine layer. It's like a sponge. If you put a sponge in the water, you can see all the water, be soaked up in the sponge. And the same what clay do. This is, and nothing else in the world besides clay can do that in that magnitude. Lime is close, but that is something that is very unique about to stabilize that humidity that is in the room. And there's some things I wish I could make a hotel. I can talk about the sustainable aspect of it, how amazing they feel. But I wish that people could stay in it and sleep in it. The humidity, the smell, the air is just so different from anything else. So I always love to go back to straw and clay. There's something there that is I'm drawn to. I'm already very excited. Any client that choose to do that, I can see they're very happy, and it's spreading. Um, um, the people and their friends and their family coming, and they see it and feel it. So I wish that more and more people want to build that way, and I see that slowly spreading around. Yeah.
Thank you. I want to add one more little fun fact, special quality about clay that I learned as a natural builder. In the humidity exchange process of clay, it winds up when it releases the water back in the air, it is about 50 times smaller of a molecule than it was when it absorbed it. And one of the results of that is it electrifies, it ionizes that water droplet in the air. And that electrostatically then attracts itself to anything floating in the air, dust, bacteria, all the stuff. And then it makes it heavier and will fall out of the air. So my whole office is clay, and I wind up dusting a lot more often. But when you first walk in, especially, no one's kicking anything up, the air is completely clean. There's nothing floating in the air anymore. So it's actively and passively forever cleaning anything out of the air. Yeah.
Any more questions for Peter?
Alan.
Hopefully, Peter, you can hear me. I'm making an assumption that I just would love if you could verify. You're using 1 inch of clay on the inside for its reservoir and thermal lag properties, and a 1/4 inch of lime plaster for vapor diffusion on the exterior, shedding, diffusion, and lack of checks. Yeah?
Yes, correct.
Okay, cool.
So outside, so we have an air barrier, and then we have a wood fiber board that is a little bit more than 2 inch. And then we have so we have a little bit of silicate in it. So it's not pure lime. So the silicate is not 100% natural, but we only have few percent in it. What it do is that we can put it in lime, need to dry out, over time, slowly. They need to have water. Here we can just really put it on and we can walk away, a very, very thin layer, and to do the same amount of job. And we can have the benefit of, really have it for, without maintenance. You don't need to go out and paint it. You don't need to have any renovations. You can, a wildfire could go through the property. You're still good. So both the maintenance that can last for a lifetime, or 2 lifetimes, and it gets stronger and stronger over time, and can take the wildfire, and it's very cost effective. Yeah.
Yeah, in fairness, then you say that the silica was one of the purposes was for water retention to slow the cure, and maybe also as a pozzolan.
Yes, so far I know, yes.
Cool.
So we can say
How do you combine plumbing and electrical?
yes. So we do 3 different things. One, if you're doing a clay plaster, we be putting in the wire inside the straw, so we could easily make a groove and be running in the stud wall. So that is typical if you're using clay, or we can also use, if you're using clay, we can use a MC wire. That is like a wire that is flexible, but it's contour. It is built to coat, and if you're using that, we can just staple them directly on the straw panel, and we clay plaster over that. or we can have a surface cavity to put a Intello Plus or paper barrier inside, and we can create a space 2.5 inch or 1.5 inch, running all our spine there, and then some people using drywall. I think it's one of our clients. All my time I have used drywall, so it's not very often that most of the people using clay or lime. Yeah.
And Kathy's got a question about if you've done any projects in Oregon or Washington.
Not yet. Not yet.
Okay, well,
Thank you so much.
You're welcome. Thank you.
very much. That worked out. Really, the hybrid worked out. Come
Good
visit
to-
us in Seattle sometime.
That would be wonderful. I would be glad to. Okay. Thank you so much.
All right.
I just wanted to, before you go, Peter, just around both Heather and Peter, thank you both so much. I mean, you guys were just dreaming is the word I keep thinking.
Pleasure to see you all. Thank you.
Could you give us your contact information?
So, oh, yeah, Peter,
Peter, can you please put your contact information in the chat?
Yes, definitely.
excellent.
So again, I'm happy to, you're welcome to reach out from you a homeowner, you are architect, you are builder, you're a developer. We're working with everybody. So if you have what could it cost? Please, if you have drawing, you're welcome to send it to me. Be happy to provide a free estimate how it will take. Be happy to jump on a call to work with exactly your project and see how we can utilize the store panel to your project. Happy to help anybody. So you can reach me on my website. So I put that on the chat, and you can look it up, and my email and phone number will be there as well.
Thanks for staying up late, Peter.
You're welcome. Thank you. Thank you.
Yeah, I wanted to just say a couple more things. Laura's got a plug. And then, how many people have actually been in a straw bale building? Something just really special about straw bale buildings. And I've seen in my own experience that when you go to a straw bale workshop or something, then you want one. And I get to say that I got Seattle's first permit for a straw bale structure. Very small bedroom edition, right? But it was really fun. It's traditional sticks and traditional bales, and then it was plastered. And it was a bunch of work parties, so. Already wanna.
Actually, Grace has asked me to talk about a hard hat tour that she's hosting for Guild members only. You have to be a Guild member to attend. It's on Bainbridge Island on July 17th at 12:30. They're gonna be working with carpools and that kind of situation to help with the ferry and getting to the site. It's near Winslow though.